Hello everybody, this is the presentation on mobile equipment power requirements. We'll be covering something very important, which is answering a major question, which is how come on the meter of your car or any machine you will have a certain maximum speed, however you could never attain that maximum speed, practically speaking. Why is that? So in order to understand that, we'll be discussing three different types of powers: the required power, the available power, and the usable power. The required power is the one required to overcome resistance. So here the question is mainly about resistance. The available power is what your motor could exert. However, the usable power is what you could use from whatever your motor does actually exert. So the required power, it's as what we mentioned, it's a question about resistance. So we need to understand what is resistance. Resistance is classified into one of two things. It's either rolling resistance. So if I'm having a vehicle moving on a level grade and I'm not pushing the accelerator, it will eventually slow down until stopping. So why is that? This is due to rolling resistance, if it is even moving on level grade. However, if we have a grade, actually there is what we call the grade resistance, which could be plus or minus. It could be actually, if it's uphill, it's a resistance. If it is downhill, it's acting in your favor. So the addition of both is what we call the total resistance or the effective resistance. So the rolling resistance, it has mainly three mechanisms. First is the friction, the internal friction within your car itself. Second is the tire flexing, the contact between the tire, the contact area between the tire and the ground or the surface it's moving on. And the shear through or ride over surface. So this is mainly depending on the type of the surface, whether it's maintained or not, poorly maintained, or asphalt or whatever. So if we want to quantify, we represent that in terms of force per unit weight of the vehicle. So if we are talking about US customer units, it's pound per ton, if pound of force, pound of resistance force per ton of weight of the vehicle. If we are talking about SI units, it's kilogram per metric ton, not short ton now. So if we look at this table, you will notice that the more rough is the surface, the higher is the resistance. So for smooth concrete, if the surface is smooth concrete, this is the lowest resistance you could ever find. Good asphalt, yes, it's very low too. However, if we are talking about very muddy earth or rotted earth, this is something that's of a very high resistance. So this makes sense. This will tell you why if you move on an asphalt road, you could attain higher speeds than if you move on on mended road made of maybe gravel or sand. This is a formula that could represent this relationship. It's relating the tire penetration to the rolling resistance to the gross vehicle weights. However, this you should not memorize this. This is an empirical formula, but you should understand that the rolling resistance is directly proportional to the gross vehicle weight, and of course is directly proportional to the tire penetration itself, which is affected by the type of the surface. So if we go back to basic mechanics and we look at this free body diagram, we'll find that the force F from equilibrium, the force F is equal to W times sine alpha. Sorry, this is when you resolve F into horizontal and vertical components, you'll find F is equal to when you resolve W into horizontal and vertical components. So F is equal to W sine alpha, and N is equal to W cosine alpha. And of course, when we have small angles, we know that sine alpha is approximately equal to tan alpha. So actually F equal W tan alpha. And this tan alpha is actually what we call the percentage grade. So this is V over H, which is the percentage grade, G as a number over 100%. So if we replace that part and we put it instead of tan alpha, we get that F is equal to W times G over 100. So if W is actually the unit weight of the vehicle, so if we are talking about US custom units, so it's 2,000 pounds per short ton. However, if we are talking about SI units, it's 1,000 kilograms per metric ton. So here, if we substitute the 2,000, we'll find the formula F equal 20 pound per ton times G. Again, for SI units, you will find it F equal 10 kilogram per ton per metric ton times G. So this is the formula that we will be using in order to convert the rolling resistance from being in terms of pound per ton to have an equivalent grade, an equivalent rolling resistance in terms of a percentage, an equivalent percentage for the rolling resistance. So then you will be able to sum them up. Now I'm able to add a percentage to get what we call the effective grade. So if we take a very nice example here, this is a cart dragged by a horse uphill. The rolling resistance is 100 pound per ton and the adverse grade is 4%. So let's discuss the situation uphill and downhill. So the equivalent grade is actually 100 pound per ton rolling resistance divided by 20 pound per ton. So this is 5%. So the effective grade uphill will be the 5% plus the 4% grade because it's acting against the weight. So this is 9%. While the effective grade downhill, this is 5% minus 4%. So this will be a 1%. So let's move on to the available power, what your motor could exert. So if we go back to dynamics, work is actually the dot product between force and distance. And since power is work per time, so actually power is the dot product between force and velocity. So if we go back to a formula like that, this is, by the way, this 375, this is a conversion factor due to the horsepower. But typically, the force, the impulse force, is equal to the power multiplied by efficiency divided by the speed multiplied by whatever conversion factor you are having, depending on your units. So here it's 375 because we are using horsepower, speed, and we are getting the impulse in terms of pound. So, but we are not memorizing this formula. We need some concept here. We need to understand the concept here. What is the constant here is the horsepower or the power of your motor. And the variable is what? The impulse force, and the other variable is the speed. So the impulse force and the speed, both are variables. So if the power is constant, that means that if I increase the force, I'll decrease the speed and vice versa. And this explains the gears within your car. So when you're talking about, when you're having a first gear, this is the highest impulse force. So this is the lowest speed. Second gear, the impulse force is less, the speed is higher. The highest gear will have the lowest force and the highest speed. This is why you shift gears while increasing your speed. That makes sense. And while shifting gears, you will notice when you get the higher gear, the rotations per minute of the motor go down. And if you try multiplying each two numbers opposite to each other, you'll find a constant number getting. So 3.3 times 13.5 thousand is very near to 7.1 times 6.2 thousand, and so on. What about the usable power? So could I use all what my motor could exert? Actually, no way. And what's the difference here between a four-wheel drive car and a regular car? A 4x4 car and a regular car. What's the difference? The difference is that the number of active wheels in a 4x4 truck or a 4x4 tractor or a 4x4 vehicle, they all contribute to applying the force. However, in a regular car, you don't have that situation. Only one axle will contribute. So depending on, here we are talking about the weight on powered running gears. So this is the weight on powered running gears, not all over the vehicle. So this depends on the issue here. And also it depends on the coefficient of traction. So people living in areas where they have ice, they know that for sure if you move on ice, your life is more like a disaster if you are fast on ice. So because the traction is really poor, the grip, the tires could not grip, and this is why in these countries they use what they call winter tires. So the coefficient of traction here is the main contributor to the usable force. So that is why if you are talking about a wet surface, the traction is much less than a dry surface. And when a maintained surface, a maintained road or amended road is much better than moving on loose sand or dry sand. And of course, this issue will differ from whether you are talking about rubber tires or tracks. But practically speaking, how could we use that stuff? So for each piece of equipment, manufacturers will supply us by a set of curves or a set of graphs. So if you look at these curves, if you compare the curve of the first gear, the second gear, and third gear, all of them, they correlate the speed to the impulse force. But you notice something very nice, that the area beneath each of these curves is equal to the other. So the area under the first gear curve is nearly equal to the area under the third gear curve. If you go and calculate it, you'll find it the same. Why is that? Because actually power is the integral of force over speed. Okay, so this is why this area is equal to that area. Also, some people could combine that concept. I mean, of course, here you could simply get the speed if you know the impulse force. But how could we know the impulse force? How could we know the impulse force? Let's now combine the available power, or sorry, the usable power and the required power together on one curve. So now we have these slanted lines. They represent the different total resistances. Grade plus rolling resistance, the effective grade, percentage effective grade. And the vertical lines, the weights. So if I know the effective grade 4% and the weight is 50 kips, so they are meeting at a certain point. The horizontal line here represents what? This represents the impulse force, the required impulse force. And when you move horizontally, you will hit what? You will hit the curve for the gear, and then you move down and you'll get your speed. This is how you could use such a chart in order to correlate the different types of powers we talked about. And also, this is what we call the retarder performance charts. If you are moving downhill, you'll use these charts. Thank you.